Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all doing well. Dear students, this lecture is for grade 8, subject chemistry. And in this lecture, we will discuss the remaining topics of chapter number 4, that is about the structure of molecules. This is my 24th lecture, and I am your lecturer, Mrs. Saira Jamal. In this lecture, we will do the self-assessment exercise 4.3 part 2, represent the formation of anions by electron dot and cross structures. We have to represent the formation of non-metals because you know that non-metals always gain electron and form anions. So one of the example of non-metal to form anion is nitrogen. Atomic number of nitrogen is 7 and it has 5 electrons in the outermost shell. As nitrogen belongs to group 5A of the periodic table, it has 5 electrons in its valence shell. It needs 3 electrons to achieve the noble gas configuration. So the electronic configuration of nitrogen is 1s2, 2s2, 2p3. You can see that P has 3 electrons while P can accommodate 6 electrons. So it has a deficiency of 3 electrons. Nitrogen will gain 3 electrons and then will have 6 electrons in the P subshell. So 6 plus 2, 8 electrons are present in the outermost shell of this nitrogen anion or trivalent nitrogen. So this trivalent nitrogen anion, it after gaining 3 electrons will have completely filled outermost shell. As you can see in this image, nitrogen has 2 electrons in the first shell and 1, 2, 3, 4, 5 electrons in the outermost shell. In order to have the same electronic configuration like the noble gases, nitrogen will gain 3 electrons and then it has 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outermost shell like the noble gases, and it will carry -3 charge. After gaining 3 electrons, nitrogen become anion and will get -3 charge. Second one is for the phosphorus. Atomic number of phosphorus is 15. Same like nitrogen, phosphorus also belongs to group 5A of the periodic table. It has 5 electrons in its outermost shell and it needs 3 electrons to complete the outermost shell or to achieve the noble gas electronic configuration. Electronic configuration of nitrogen is 1s2, 2s2, 2p6, 3s2, 3p3. Again, same like nitrogen, you can see that the p subshell of phosphorus is half filled. It has 3 electrons and it needs 3 more electrons to complete the outermost shell. Outermost shell is 3 and it has 3 plus 2, 5 electrons. It will gain 3 more electrons and then in turn will have 8 electrons in the outermost shell. After gaining 3 electrons, you can see nitrogen has 6 plus 2, 8 electrons in the outermost shell. You can see in this image nitrogen has 1, 2, 3, 4, 5 electrons in the outermost shell and 2 electrons in the first shell, 8 electrons in the second and 5 electrons in the third shell. It will gain 3 electrons and then will form the phosphorus anion, trivalent anion, same like the nitrogen. Next one is bromine. Bromine atomic number 35 and it will form bromide ion. Bromine belongs to group 7A of the periodic table. It has 7 electrons in its outermost shell and it needs 1 electron to achieve noble gas electronic configuration. You can see the configuration of bromine. This is bromine. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. So the outermost shell is 4. 2 and plus 5 are 7. So bromine has 7 electrons in the outermost shell. It will gain one more electron and will have configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 and 4p6. 4p has 5 electrons before, and now after gaining 1 electron it is 4p6. So 6 plus 2, 8 electrons are present in the outermost shell, hence the outermost shell of bromine will complete. This is bromide ion, okay, Br minus 1, not phosphorus. Br minus 1 bromide ion. You can see in this image representation of by electron dot and cross structure. This is the structure of bromine. Bromine has 2 electrons in the first shell, 8 electrons in the second, 18 electrons in the third, and the remaining 7 electrons in the fourth or outermost shell. So it has 1, 2, 3, 4, 5, 6, 7 electrons. It will gain one more electron and then in turn will have 8 electronic configuration. It will form minus 1 univalent anion of bromine, which is called bromide ion. The last one is of hydrogen. Hydrogen, you know, is present in group number 1A of the periodic table. It has 1 electron in its outermost shell and it needs one more electron to achieve noble gas configuration. So hydrogen has 1 electron in the outermost shell. It will gain 1 electron and will form anion of hydrogen. Hydrogen has 1 electron. After gaining 1 electron, it will form anion of hydrogen having minus 1 charge. After getting knowledge or information about the anions and cations, now coming towards the formation of ionic bond. As I told you that ionic bond is a bond which is formed between the oppositively charged ions. So in this case we will see for each of the following pair of atoms use electron dot and cross structure to write the equation for the following or for the formation of ionic bond between these compounds. The first case is sodium and chlorine. So we have to solve the problem by following steps. The metal atoms form cations. The metal atom form cations and non-metal atom form anion. Metal loses electron and non-metal gain electrons. The number of electrons lost by a metal atom of group 1A, 2A and 3A are equal to the group number. In group 1A element loses 1 electron, 2A loses 2 electrons and 3A loses 3 electrons. To write the final form of the equation, you need to know the simplest ratio of cations to anion that you require for the neutral, for this compound or for the neutral compound. Write equation using electron dot and cross structures. Sodium and chlorine are there. Sodium is metal and chlorine is non-metal. So metal, I told you, they tend to lose electrons and non-metal atom tend to gain electrons to acquire electronic configuration of nearest noble gas. So since sodium atom has 1 electron in the outermost shell, it loses 1 electron to form sodium ion or sodium cation, while chlorine atom has 7 electrons in its outermost shell. It needs only 1 electron to complete octet, so it gains 1 electron to form chloride ion. For every sodium ion, you need 1 chloride ion. The dot structure of sodium and the cross structure of chlorine. So chlorine will sodium will loses 1 electron and chlorine will gain 1 electron and then they will form cation and anion. These anion and cation will attract each other with a force which is called electrostatic force or ionic bond. This is ionic bond formation of sodium and chloride ion. Example 4.4 part B. We have to represent electron dot and cross structure for the formation of magnesium and fluorine, or magnesium or fluoride ion. So as atomic magnesium atom has two electrons in its outermost shell, it loses two electrons to form magnesium divalent magnesium cation. Since fluorine atom has seven electrons in the outermost shell, so it will gain one electron to form fluoride. And you can see magnesium, and then here we use two fluoride ion. Why we use two fluoride ion? Because each magnesium ion we need two fluoride ion, because each magnesium loses two electrons while fluorine gains one electron. So we need two fluoride ions and each will gain one electron. That's why magnesium is one and fluoride ions are two. Magnesium will loses two electron, one electron to this fluorine atom and one to this fluorine atom, and then they are converted into magnesium ion and fluoride ions, two fluoride ions. Self-assessment exercise 4.4, recognize the following compounds as having ionic bond. First case is magnesium and oxygen. So magnesium is metal and oxygen is non-metal. So it is ionic compound because I told you when a molecule is formed by from metal and non-metal, then it is called ionic bond. Magnesium atom has two electrons in the outermost shell, and the fluorine has seven, like oxygen has six electrons in the outermost shell. So magnesium will loses two electrons and will form cation, and oxygen will gain two electrons and will form anion. Then the cation and anion will attract each other with the force, which is called ionic bond or electrostatic bond. You can see here magnesium, all the electrons of magnesium are represented with dots, and that of oxygen is represented with cross. And I told you that each oxygen has six electrons in the outermost shell. So in order to complete the outermost shell or to have the configuration like the noble gases, oxygen will gain two electrons. Magnesium will loses two electrons and form cation, while oxygen will gain two electrons and will form anion. Then these oppositively charged ions will attract each other with a force which is called ionic bond or electrostatic force. Next example is for aluminium and chlorine. Aluminium is metal and chlorine is non-metal. So it is ionic compound. Aluminium has three electrons in the outermost shell, and it will lose three electrons to form trivalent cation, while the chlorine atom has seven electrons in the outermost shell. It gains only one electron to form anion. For every aluminium ion, you need three chloride ions because each chlorine atom will gain only one electron, and aluminium is loses three electrons, so we need three chloride ions. You can see in this image one aluminium and there are three chloride ions or three chlorine atoms. The reason is that aluminium loses three electrons and one electron will gain by each atom of each chlorine atom to form chloride ions and aluminium ion. Self-assessment exercise 4.5, recognize the following compounds as having ionic bond. The first case is potassium chloride. Potassium is metal and it is present in first group of the periodic table, and chlorine is non-metal. It is present in the group 7 of the periodic table. So it is ionic compound because metal and non-metals are there. Potassium atom has one electron in outermost shell. It loses one electron to form potassium ion. Since chlorine atom has seven electrons in outermost shell, so it gains one electron to form chloride ion. For every potassium ion, you need one chloride ion. You can see here potassium ion and chloride ion. Potassium has two electrons in the first shell, eight in the second, eight in the third, and one in the last shell. And in this case, we have two, in case of chlorine, two electrons in the first shell, eight in the second, and seven in the third. So potassium will loses one electron, and chlorine will gain that one electron. So chlorine will form chloride ion or anion, where potassium will form the cation. and then these oppositively charged ions will attract each other with a force, which is called ionic bond. Next part is for magnesium fluoride. Magnesium is metal and fluorine is non-metal. So it is ionic compound. Magnesium atom has 2 electrons in outermost shell. It will loses those 2 electrons and will form magnesium cation. Since fluorine atom has 7 electrons in the outermost shell, so it gains 1 electron to form fluoride ion. For every magnesium ion, you need 2 fluoride ions because each magnesium atom loses 2 electrons. So each fluorine atom will gain one electron and then will form the stable compound. This was all about the formation of ionic bond between metal and non-metal, and then now coming toward the second type of chemical bond, that is the covalent bond. What is covalent bond? A bond which is formed by mutual sharing of electrons between two atoms. Mutual sharing means equal sharing of electrons between two atoms is called covalent bond. These compounds are made up of non-metal atoms. Like the non-metal atoms combine together or react together to form covalent compounds. Non-metals have high ionization energy, so non-metal do not lose electron, they always gain electron. So they'll gain electron to form a chemical bond which is called chemical, or it is called covalent bond. Covalent bond is also known as molecular bond. We can represent the formation of covalent bond between two atoms by using electron dot and cross structure for the atoms and the resulting molecule. You can see in this image all the electrons are identical and cannot be differentiated. A shared pair of electrons is also represented by a dash in a molecule. You can see between two hydrogen atoms there is a dash. This dash shows covalent bond between the two hydrogen atoms. Formation of hydrogen atom, the electron of one hydrogen will represent by dot and that of the other hydrogen by cross. So they'll share electron. You can see electron density is between the two atoms and then they will form bond. The dash show the covalent bond or H2 formation will take place. Then types of covalent bond depending upon the number of shared electron pairs. The covalent bond is classified into 3 types. On the basis of shared pair of electrons, the covalent bond is classified into 3 types. Single covalent bond, double covalent bond, and triple covalent bond. Single covalent bond, a bond that is formed by the mutual sharing of one electron pair is called single covalent bond. When only one electron is shared by each atom, then the bond form is called single covalent bond. Formation of covalent bond in hydrogen molecule is one of the example. Hydrogen atom has a single valence electron. It has only one electron in the outermost shell. Two hydrogen atoms share their valence electrons to form a diatomic molecule. In the formation of this molecule, each hydrogen atom achieves the electronic configuration of noble gas, that is helium, which has 2 electrons in the outermost shell. So hydrogen, after gaining 1 electron, will also have configuration same like the helium. An electron pair in the region between the two atoms is attracted to both hydrogen nuclei. This means it is a more stable situation than that exists in separate atoms. Because of this stability, two atoms form a covalent bond. This is the stable form. The electrons are in the stable form, and that's why the stability of these atoms retain. You can see two hydrogen atoms, they react together, will share electron between the region between the two nuclei and will form hydrogen molecule. Formation of covalent bond in F2, which is the second example, F2 of single covalent bond. Fluorine belongs to group 7A and it has 7 electrons in the outermost shell, and fluorine needs only 1 electron to attain the noble gas configuration. or to complete its outermost shell. Thus, two fluorine atoms share an electron pair and achieved electronic configuration of neon, which is noble gas. For sharing, each fluorine atom contributes one electron to complete the octet. Fluorine, the electrons of one fluorine atom will represent by crosses and the other by dots, and they are 7 7. So they will share one electron, and that's why 1 2 3 4 5 6 7 8 8 electrons will complete it in each case. Next type of covalent bond is double covalent bond. A bond that is formed by the sharing of two electron pairs is called double covalent bond when two electron pairs share. Example are formation of covalent bond in oxygen molecule. Oxygen belongs to group 6A of the periodic table and it has 6 electrons in the outermost shell. It needs 2 more electrons to complete the outermost shell, same like the noble gases or group 8 elements. Thus, two oxygen atoms share 2 electron pairs and achieve electronic configuration of noble gases. For sharing, each oxygen atom contributes 2 electrons to complete the octet. In this image, you can see oxygen atom. There are two oxygen atoms. Electrons of one oxygen atom represented by crosses and the other by dots. And then they share two pair of electron, one to two crosses and one to two dots. So the electron density is between the nuclei of two atoms. And you can see here, you can also represent this electron dot and cross structure, which is also called Lewis structure in this form. You can see we have 2, 2, 4, 5, 6, 7, 8, 8 electrons with this oxygen atom and 2, 2, 4, 5, 6, 7, 8, 8 electrons in this oxygen atom. So the octet of all the oxygen atom will be completely filled. Triple covalent bond, a bond that is formed by the sharing of 3 electron pairs is called triple covalent bond. For example, formation of covalent bond in nitrogen molecule. Nitrogen belongs to group 5A, so it has 5 electrons in the valence shell. It needs 3 electrons to attain the noble gas electronic configuration. The two nitrogen atoms share 3 electron pairs and achieve electronic configuration of noble gases. For sharing, each nitrogen atom contributes 3 electrons to complete the octet. You can see in this image, nitrogen has 5 electrons in the outermost shell and it needs 3 electrons. So after sharing 3 electron pairs, 3 crosses by one nitrogen atom and 3 dots by another nitrogen atom, and then in turn they will share 1, 2, 3, 4, 5, 6, 6 electrons or 3 electron pairs and will form triple covalent bond. Triple covalent bond in nitrogen can also be represented by 3 dashes. The 3 dashes show triple covalent bond, and these two electrons are called the lone pair electron or non-bonding electron pair, which does not participate in bond formation. Next is types of covalent bond on the basis of electronegativity difference. The previous classification was on the basis of the number of electron pair which they shared, but this classification is on the basis of the electronegativity of combining element. The covalent bond is classified into two types on the basis of electronegativity difference: polar covalent bond and non-polar covalent bond. Polar covalent bond, when two identical atom means similar atom, shared electron pairs, both the atom will exert the same force on the shared electron pair. Such a covalent bond is called uh, non-polar covalent bond. Non-polar covalent bond. For example, H2O2, N2, etc. They are made up of similar atom, so they have no electronegativity difference. As a result, the bond will call non-polar covalent bond. In case of H2O2, N2. Non-polar covalent bond, when two different atoms shared electron pair, both the atom exert different forces on the shared electron pair. Then what will happen? More electronegative atom will pull electron more towards itself or with a greater force from the other. So more electronegative atom partially draws electron density towards itself. This make it partially negatively charged and other atom partially positively charged. Such a covalent bond is called non-polar covalent bond. Example of the non-polar covalent bonds are uh, not non-polar, sorry, polar covalent bond. It is polar covalent bond. Poles are formed, positive pole and negative poles are formed, so it is called polar covalent bond. An example of polar covalent bonds are HCl because it is made up of two dissimilar atoms, hydrogen and chlorine, hydrogen and oxygen, nitrogen and hydrogen, hydrogen, carbon, nitrogen, carbon and oxygen. So different atoms combine together to form a bond which is called polar covalent bond. But the similar atom combine to form the non-polar covalent bond. So as I told you that this classification is on the basis of the difference in the electronegativity of two atoms. If two different atoms which have different electronegativity value, they will pull the electrons with different force. So that electron which is pulling the electron more towards itself, especially the halogens or group 7a elements, they have high electronegativity value and high electron affinity. So they will pull the electron pair more towards themselves. As a result, the partial positive charge and partial negative charge will appear on each atom, which will make the molecule polar in nature. So HCN, H2O, ammonia, and hydrogen cyanide, carbon dioxide, they are polar molecules. Okay, over here I mentioned mistakenly non-polar, but these are polar covalent bond. The bond is called polar covalent bond. So dear students, hope you understand this lecture. Inshallah, in next lecture we will continue this chapter. Till then, take care. Allah.